Assalamu alaikum and very good day. Welcome back to core software testing. Here we will discuss in this module or this part about evaluation the test cases by using a mutation testing approach. At the end of this topic, the aim is to the student discover the purpose of mutation testing, the need of mutation testing, what is the use of mutation testing, and how can we use this mutation testing to help to generate a test cases or to select the test cases. Expected outcomes of this, the student be able to design the testing documentation with adequate test cases using a mutation testing. Some references here can be used for students to get more knowledge. So what is a mutation testing? We learned in the previous lectures different test design techniques and different test design approaches based on the black box or white box or a other approach. In this topic, we will discuss about the mutation testing. Mutation testing is not a strategy to design or to create a test cases. It is a technique that will be used to help to select the best test cases that have been designed from the previous techniques or approach have been used. So mutation testing, it is a testing approach that focus on measuring the adequacy of the test cases. It can be used with the conjunction of the other test design techniques. As mentioned here in the previous slide, the test case is adequate if ever even if only it will be detect all false or all mutant. So the all mutant should be killed by that test case. If any one of these mutants still alive, so this test case not useful and is not inadequate, so inadequate test case and should be eliminated from the test list. The example of mutant program. So we have the original program here, which is the code here. We have operator, we introduce only a single fault. So we select each line that in that code, we thought that that test case can apply here if we have a data the test case have x value and y values, and then we can apply, let's say x has a 10 and y has a 10. Then we say that this is the test case when x is 10 and y is 10. What is the output of this code? Alright, so this is the original, and we have a test case. Let's say we have test case number 1, x and y. X has 5, y have 2. So here, if x is greater than y, so it will print x. So the output here is 5. So the output, out here is print 5. Alright, so here, then here the mutant. So mutant x, apply the same, but here we introduce is smaller. Here s is greater. This is the original. So this is the mutant, x is smaller. So here we have a x is smaller, then we have, if x is 5 and this one is 2, so will not print nothing here, will not be well printed. Here this test case is adequate by killing this mutant. So the process here, as mentioned in the previous slide, we create several mutants by changing a single fault in the original. Let's say we create 3 mutants to the original, then we apply the test cases. Then let's say we have test case 1, test case 2, and several test cases. Test case 1, it will be apply here, the original will be sent and produce result, and the original with the mutant number 1 not same, with the mutant number 2 not same, with the mutant number 3 also not same. So here all the mutants killed, yeah, because not same as the original, so I select test case 1. So test case 1 is adequate. If test case 2 apply to the original, produce a result, and then when I compare to mutant number 1, have same result, mutant number 2 not same, mutant number 3 not same. So here I have one mutant still alive, so that test case not adequate, so I select another test case 3, and so on until I finish all the test cases, measuring to find the best selected test cases to be used later to test the system. So how can categorize of mutation operators? Based on the operators, we have for example here the 5 is greater than y. If we have a replacing the x by 5, we can create this is a mutant, or by replacing y by 5, then also this is a mutant. So we can create many mutants as we can, depend on changing on the operations here. Also, if you have some equations such as a equal b times c minus d, so here there are 2 operations here, multiply and subtraction. We can create 8 mutants, 4 mutants by changing only this, by changing to addition, subtraction, power or division, and the other 4s by keeping the multiply and changing only here this part, and changing this one the subtraction by the addition, also by or changing by a multiplication, or change it by power, or change it by a division. So we can create it 4 based on the operation subtraction, or 4 based on the multiplication. Of course, also in the previous operators, here we can just change the condition here. Instead of greater, we make it equal, greater and equal also to test the boundaries, or greater to the plus of the value of y by increasing. So here also other mutants. Also, mutant can be for modify the statement by delete the else part if we have a if else statement, or we delete the entire of the if else statement, or by replacing third line of if else, and then we have a return statement in that conditions. So let's say we have an exercise here. We have the original is here, this original equation. We can create mutant number 1, mutant number 2, mutant number 3, mutant number 4. So how many test size here? We have 4 mutants, so we have a 4. And we have a test list here. X have several values. X can get either -1 or 0 or 1 or 10 or 100. So we want to test each one of these test list. So we will test the value of X. When X is -1, we have 4 mutants. When X is -1, it will produce 1 minus 1, 1 minus minus 1. It will become 1 over 2. This is the result. And here, if we apply -1 here, 1 plus -1, it will be 1 over 0. 1 over 0, it is infinity. And then mutant number 2, 1 time -1, it become -1. So here the result is -1. As well as here 1 to power -1, 1 to power -1, which is 1, so the result is 1. 1 over 1 -1, so it will be -1. So this is the original. If any one of these mutants produce same result as the original here have, none of them, so the live mutant is 0. And the killed mutant, of course, 1, 2, 3, 4 mutant has been or have been killed. So here is 100% score of mutant killed. And then we apply again 0. If we have a, let's say, erase this part here, then if we apply the 0, so 0 will produce 1 over 1 minus 0, the result is 1. So here 1 over 1 plus 0, so it will be 1 over 1, it will be the result is 1. So here 1 to power of 1 times 0, 1 over 0, it will be have infinity. As well as here we have 1 over 1 to power 0, it will be 1, so the result is 1. And if we apply 1 to power over 0, so it will be infinity, and 1 over infinity, it will be 0. So here, two different, this one is different, this is will be killed, and this one will be killed. So this result, original produce 1, this mutant produced the same result, and mutant number 3 produced the same result. So here, how many test size? I have 4 in the value 0, on the test case of value 0. So is there still live mutant? Yeah, still have 2 mutant live, so I have a 2. And killed 2. So here the score is 50%. So this the value of X is not adequate. The value of -1 is good to be used as a test list. So you can apply to find the adequacy of each, the 1, the 10, the 100. If these are all the mutants will be killed, so they can be as a good test cases to be used for testing the system. You can apply any other examples to increase your understanding. If you have any questions, maybe you can drop me an email. Thank you for listening for the mutation testing, and have a nice day.